ArduiWeKnow. My name is Ahmed Ashraf, and today we will talk about our project in the embedded systems course. We will start first by showing you the Bluetooth module and the Arduino, the gesture control of the project. Here's our Bluetooth module. This Bluetooth, we are connecting it with a mobile application, Android mobile application, in order to control the car. And here's our application. So now we will show you how the application controls. This is forward, and this is backward, and this is left, and this is right. And here's an example. So this is forward, this is backward, and this is right, and this is left. So we used byte encoding binaries as zeros and ones. If this translates in the code as 2, this gives us right, left, sorry, and this if we have 1, this is right, and if we have if it's translated into 4, this means forward, and 8 is backward.
A few moments later.
This is Daniel from Team Arduino in the Embedded Systems course, and I will continue what my friend Ahmed has just said. So, to set up the Bluetooth module, we had to set the baud rate of it to 2600. So after setting the baud rate, we had to receive the data serially from the Android device and transmit it to the Arduino. And then to differentiate between directions, we had to use the accelerometer in the Arduino device. For example, this tablet, which uses the 3 axes, X, Y, and Z. So we use the Z axis to control the front and back, and the Y axis for the left and right. So this way, this is in the Z direction with the front, and this is the Z direction, the backwards, and this is the Y direction left, right, and this is the Y direction left. So after setting the baud rate, we had to receive the data serially from the Android device and transmit it to the Arduino. And then to differentiate between directions, we had to use the accelerometer in the Arduino device. For example, this tablet, which uses the 3 axes, X, Y, and Z. So we use the Z axis to control the front and back, and the Y axis for the left and right. So this way, this is in the Z direction with the front, and this is the Z direction, the backwards, and this is the Y direction left, right, and this is the Y direction left.
So much later that the old narrator got tired of waiting and they had to hire a new one.
Hello, my name is Amir Zaghlul from the team ArduiWeKnow, and today I'm going to talk about the code that we use to integrate the car together.
2,000 years later.
To start with the setup, we configure the pins used in the ultrasonic sensor. Then in the main loop, we send the signal from the ultrasonic sensor, and then using the delay in the signal, we calculate the distance from the car to the nearest obstacle ahead. And in this part, we wait for the serial input received from the Bluetooth module to be ready, and then here we check for the received byte that is encoded by the Android app, where the least significant bits, 4 bits, represent directions, so being backward, forward, right, and left. Then when we're moving forward, we check for the distance to be less than 30 centimeters, and accordingly we send the signals for the H-bridge control motor to decide which direction to go, right, left, forward, and backward. And the top part here, it's about when the Android app doesn't send the signals, sometimes there's a delay in the signal, so we have to put a condition that checks beforehand whether the distance is less than 30 or greater than 30 to move forward or not. Thank you.
Many months later.
My name is Ziad Yasser. I'm 37-MAT student. I'm a team member in a team called Arduino, and I'm going to explain to you how the ultrasonic works in our project. We use the ultrasonic in front of the car to detect the objects or the walls, and whenever it detects an object that comes close to the car, it makes it stop immediately. The ultrasonic works with 4 main pins. 2 pins to control the power, the ground and the VCC, and 2 other pins, the echo and the trigger. The echo generates waves and the trigger receives them, and the ultrasonic calculates the distance through calculating the speed of the waves and the time till the waves comes back from hitting the object till the trigger pin. And now I'm going to explain to you how we connected the ultrasonic to our car.
So we have the ultrasonic that is connected to the car. We have put it in front of the car. So whenever it detects an object in less than 30 centimeters, it stops immediately. Here we have the 4 pins, the ground and the VCC, and the trigger and the echo pins that are connected to the Arduino. So whenever I have an object like my hand over here, it makes the car stops immediately if it's in less than 30 centimeters as a distance.
One eternity later.
Hi, my name is George. I was the one responsible for connecting the voltage bridge to the motors. First, I connected the voltage ground and source to the bridge, and then I connected motors to the side as shown. Then I connected the PWM ports to the Arduino through this port and the direction ports through this ports. The voltage inputs were the one responsible for providing voltage to the H bridge, and the 2 pins at the side of the bridge were responsible for driving voltage to the motors. The two wires connected to the PWM Arduinos were responsible for providing voltage to the motors as I chose them from the Arduino code. Finally, these 2 pins for each motors were used to provide the direction of the motor. One of them must be high, the other must be low, and if we reverse them, the motor direction is reversed. If both are low, the motor stops moving.